I'm always afraid when former students do the introductions what comes to light, but thank you, Casey and Gurley have kind of kept quiet about all the things which transpired at UCLA. So yesterday with Russell Schilling, you had the money talk. I cannot offer you any money, but hopefully I can offer you some new ideas, and that's why I titled my presentation, Leveling Up Serious Gaming, Playing and Making Games for Learning, to talk about the things you didn't hear yesterday, but which I believe are really important. And this slide shouldn't come to any of you as a surprise. During the last 10 years, we had a real kind of renaissance of serious gaming in national policy reports, books which kind of touted the many benefits which games offer to learning. And also, just recently, there have been a number of meta-analyses, not just the one which Joan Herman presented yesterday by Doug Clark, conducted for SRI, but actually many more. And what's even more surprising, not all of them are positive. Many of them actually see much more detriment than opportunities in serious gaming. So I think the question is still out on how we measure and assess this. And then last but not least, just a few months ago, the first kind of really trade book by Greg Toppo, USA Today education reporter, came out. And I think, you know, who kind of popularizes the notion for the masses on what games have to offer, and actually a number of people's whose work is presented there. But again, this book, I mean, as wonderful as it helps people to understand that gaming isn't just all about violence, but also some of the positive things, still forgets to focuses entirely in serious gaming on what I call instructionist approaches for playing games for learning. And what I want to do today is introduce you to the forgotten side, to the constructionist perspective, which I believe should actually be also part of serious gaming, where we look at making games for learning. And ultimately, what I'm trying to have a conversation with you about is that we should move to an approach what I call connected gaming, where we look at playing and making games for learning as two sides of the coin, as a continuum rather as opposites. So how am I going to do this? 4 things. I'm going to talk a little bit about what constructionist gaming is, where it came from. And then I'll actually present to you some results from a synthesis which we just conducted in reviewing the field on what has happened over the last 20 years. And then I issue some challenges, what I see around, and close with connected gaming. So let me start out with constructionist approaches, and for the sake of the argument, I've kind of create clear delineation between instructionist versus constructionist, even though, as you can see from my introduction, I see them rather as a continuum. So where did this come from? And many of you might actually be surprised. Over 20 years ago, when I was at the MIT Media Lab, we actually were already looking at serious gaming, but we were looking at it from the perspective of kids programming. And what you have here is actually an image of the school, Project Headlight at the time, where we had hundreds of computers in elementary school in what was then a fairly under-resourced community. Now this has changed in Boston. And Minds in Play, the book which I wrote, which you do not buy, you can get that for free from my website. I got the copyright back. So, and I want to show you just an excerpt from the clip so you can see that the technology, which were 256K machines at the time, actually allowed kids to engage in making their own games.
It's demo time for parents at the Hennigan School in Boston.
He will ask you a fraction problem. If you get it wrong, you will become mentally default.
I don't know what's wrong with it.
After months of work, the 5th grade students are showing off the computer games they created. Even the principal is here to take a try. children are using the programming language Logo, invented by this man, Seymour Papert. As part of a bold MIT Media Lab experiment known as Project Headlight, Papert, his research team, and the Hennigan teachers are developing methods to put inner-city children in charge of their own learning. Instead of using purchased software like most schools, Project Headlight challenges the students to use Logo to create their own software.
How did you decide what to put in your messages when you get it right?
Well, they had basically all the same. I don't know. I just thought it encouraged them if it was right.
What do you say when they're wrong?
That's wrong, try it again.
In the design process, they become expert programmers. They draw, manipulate shapes, even guide a skier down the slope. And like all the students, this one is built in a surprise. When the skier hits a bald spot, a fraction quiz. No run-of-the-mill video games. These are designed to teach mathematics. Abigail has chosen to design her fraction game around the Greek myths.
You want to go to the home of Zeus, but the map was ripped up by the Greek god Hades. All the Greek gods and goddesses have a fraction in the map. You're to go to the gods and goddesses one at a time.
Her toughest challenge involves allowing the user to choose an answer from the quiz. She's had to learn the hows and whys of the ifs and thens.
The hardest thing about this is making the program for what your answer is to the fraction problem. Like, if you push A, then you do this, and then if you push B, then this happens, and C, then this other thing happens. So it's really hard.
The fact that a 9-year-old is learning such sophisticated programming concepts is a testament to Project Headlight's success. And for Abigail, the command of the computer allows her to devote her attention to what she really enjoys. Designing a Nintendo-style interface and creating a compelling story around the gods. Ginny has designed her fraction game around a spider web. Like her classmates, she's learned advanced programming. She's also learned the advantage of producing her own game.
Because you make your own game and you can play it anytime you want. But in Nintendo, this right here, you don't have to buy it because you're the one who's making it.
With Nintendo as a model, she's even designed her own game box.
Like, at first I didn't know how to design the web. And so the art teacher helped me and I designed it.
In fact, as part of the project, all of the children package their games and promote them with an ad campaign. These integral activities make this project unlike any textbook exercise. The students here are designing a real product from start to finish. And through the process, they learn about every advertising medium. They even produce TV commercials.
If you play this game, play it good, you may grow up to be like Ronald Reagan. Wow.
By now you should be all awake.
Town is awesome. It's spooky, it's scary, and it's exciting. And it's by TCA.
So I show you this, to make several points. You know, these weren't fancy computers, and kids were designing this as part of their computer class, which, as many of you can imagine, more than a quarter of a century, was fairly unusual that kids had daily access to a computer. But then this wasn't at a far distant computer lab. It was actually part of their mathematics class. They were learning about fractions, and they were designing software for other students, younger students in their school. And as you also gathered from the description, this wasn't just about the coding, about the making games. It was also integration of language arts. Many of you recognize probably the propaganda unit, which is part of 4th grade. as well as the art. I mean, there were days when games actually came in boxes, you know, those are long gone. But I mean, so it was a whole curriculum, and the idea of making games for learning was kind of situated. And what you see here, the kind of pedagogical model was behind, not to teach coding for the sake of coding, like millions of kids actually were learning coding during the first wave of programming, but to situate it in a context, games, which even then, and as you could tell, Nintendo was really the game of the day, was popular, and then to think about an instructional strategy. And it's very surprising, even today, I conducted a quasi-experimental design. I actually had a treatment group and 2 control groups to compare them to students in their school who learned programming in fractions in a different way. The first control group didn't write a big game, they just wrote lots of little small programs, whereas the second control group was even more typical on what students during that time, they only had 1 hour computer lab per day, and both of those controls had mathematics separate from the programming. And so the pre and post tests actually showed that the students in the treatment conditions significantly improved not only their understanding of programming, but also of fractions. And so this kind of integrated content and coding of making games became an example of how we can think about programming. Nowadays, of course, the games which kids design look very different from the pixelated screens you just saw. Those are some examples of the current activities, and it's probably one of the most popular activities with which we see kids engaging online, making their own games. And likewise, it's not just making their own games alone, they do this in a part of a community. So we have actually massive online communities, and the Scratch community, which I helped design with Mitchell Resnick at MIT, is a great example. I think nearly 40% of all the programs which are uploaded there, minute by minute, are some variation of games which kids have created on their own, but these are not the only examples. So I wondered, this what you saw was nearly a quarter century ago. What do kids actually learn when they make games? So last year with Quinn Burke together, I set out to do a synthesis, not a meta-analysis, first to kind of survey over the last 20 years by searching different databases, educational databases, the web, and hey, I used my own book because it was the first study of its kind as a backtrack device, and I identified 56 studies, empirical studies, both case studies as well as large-scale implementation, and tried to understand what people were learning. And what I found in these 56 studies, we had over 9,000 students from elementary to high school who participated in various studies. And the largest group of students actually came from the middle schools. So it seems to be a right target, 56% of those studies, followed by high school students, 20%, and then elementary students. And you also see that a large part of these projects actually has boys and girls together. An equally large number is unspecified, and it's even worse if you look at the diversity. More than 50% of the study did not specify who was actually participating. And then when you see what's also surprising, at least the research, more than half actually took place in school. And an equally smaller part in clubs, and then very few studies actually online. So we have a large body of information, but it's kind of tilted towards some areas. There's only one experimental study I was able to identify by Dutch researchers who actually compared playing versus making games. And I mention it here because it shows, of course, that constructing your own game is significantly advantageous in terms of motivation and deep learning strategy. But lo and behold, the studies we have don't have a rigorous design. And the one aspect which of course stands out when you look at making games for learning is that kids learn some form of coding, of programming. There's unfortunately, as some of you might know, no agreement on what learning programming actually means, whether you call it computational thinking or something else. And so I decided to kind of take a concept which Mitchell Resnick and Karen Brennan have developed, and they focus on concepts, you know, like loops, conditionals, particular things which are taught, as well as practices like debugging, reusing, iterating, as well as perspectives. How does kind of kids' understanding of computing and in general expands? And then we had two other categories which we could identify in these papers, where the learning of coding, like in the fraction game study, was actually connected to other academic content, be it math, science, or language arts. And finally, another category was what I called cognition, or learning about learning, kind of problem solving and creativity. And here is just a first glimpse of you of the distribution of where, I mean, looking overall, these 56 studies. And by the way, there's multiple coding. Some studies obviously focused on more than just as one aspect. And so we see that nearly 1/2 of the studies, it's a little bit less, have involving some form of concepts, practices, or perspectives. And then 1/3 looks at the learning about learning, and then also content. So what we see here is at least a first kind of perspective if we want to think about making games for learning as a kind of equivalent to playing games for learning, where the majority of the conference and also the large majority of the research has focused on, I think we can actually find some compelling evidence that this approach is a success. I mean, I haven't evaluated the outcomes of the study. That would be a focus of a meta-analysis. This was a synthesis just to kind of gauge where the field is. And so what we see, I mean, as one of the positive outcomes, no matter which kind of programming tool, and of course I'm partial to Logo and Scratch, but there are many other ones which are equally successful in introducing students to coding. And I'm very fond not just to think about it as computational thinking, which is kind of the buzzword which is making the rounds now in bringing students back into computing, but about computational participation, because I don't think about learning programming to code as an individual activity, but rather as a participatory one. Maybe this is just a kind of linguistic game, but I think it's an important emphasis to keep in mind. I want to also issue a few notes of caution, and some of them resonate very well with what Joan Herman yesterday pointed out, that obviously what kids designed as games varied dramatically, from the 2-hour study by the Dutch researchers to the study of 3 to 4 months, where kids spent obviously close to 100 hours of designing and programming their games. There's also the challenge on what is being actually assessed as programming or coding. Since we don't have a consensus in the field, that's something we need to establish. I kind of chose a meta framework, at least to be able to summarize the results. And then also the collection of data, I mean, was pretty dismal. And you know, hey, it's computer scientists at work. They don't understand anything about data collection and assessment. We also have a surprising lack of negative findings. There were actually only 2 studies which I could identify by Judy Robertson from the UK, who found that even though making games helped girls to kind of develop computational competence, it didn't broaden their perspectives of computing. And this was a fairly large study conducted in over 26 K-8 schools with over 900 students. We also, very surprising, have a lack of study and collaboration, which, I mean, given how that gaming is a very collaborative activity and designing as well, we have very little information on how to design teams and support students, not just on their own, but also together. And then finally, there were very few studies which actually looked at online. And this is surprising. I mean, given if we step outside of school, we see online as one of the areas where game design takes place in massive numbers. And I'll say a little bit more about this. So this is obviously, I think, great material for future research. But I'm bringing this up because all the discussions on the policy level, all the discussions in research have focused on instructionist gaming. And so here we have now for the first time, I mean, evidence that making games for learning is an equally powerful approach. And I want to just alert that Jill Denner and Linda Werner from ETC have an NSF grant to conduct an even more extensive synthesis, which will be coming out soon. The results from this study will come out in the Journal of Educational Psychology soon. And then if you want to have a really extensive version, the book is coming out in fall 2016. So now that I've kind of given you the run that constructionist gaming is something we should pay attention to, I also want to kind of point out some challenges I see both in the research on serious gaming, but also in the research on constructionist gaming. And I've kind of chosen 3 different angles about understanding participation, broadening participation, and deepening participation, because I think we often focus on broadening participation, but we don't really know what it means. And I think the next challenge is actually moving from broadening to deepening participation if we really want to achieve the learning potential. So I can only offer you, in terms of understanding participation, I know here at this conference and the panel which will follow me, there's a lot of talk about big data. I mean, everybody's into data mining. I'm also into data mining, because I think actually when you work with massive communities, you can't discern with the naked eye what's going on. When millions of kids participate projects and you only see the front page, you have no idea. So in a virtual world called Wyville, we actually did some of this big data, and I'll just give you some glimpses, because the point I want to make, big data isn't everything. What you really should be focusing on is what I call rich data. And it's a combination of big data and thick data. So big data is the data miner, understanding, for instance, what are the player profiles? And we do know in these massive communities, not everybody participates equally. We have a fairly small group core players, 5 to 10%, who are very active, and the rest are kind of lingering on the periphery. And you can kind of then pull out individual players like here from a group, and even if they're all in the same group, they actually have very different profiles in terms of what they do. And this is data collected over a 6-month time period, following kids 24/7. This had over, I think, 100 million data points, which you see condensed here across different activities and time periods. So what we decided to do, this doesn't really help us understand what kids do. We decided to go for thick data. This is something which I heard very little at this conference. Yes, qualitative research, ethnography. We did case studies. This is Zoe, an African-American student who was desperately looking in Wyville for African-American body parts. No, there's no cannibalism going on. She was just trying to create her avatar that the head and the body matched, and it turned out to be really difficult. And this was obviously a concern to her. And in order to get the body parts, she had to go to the trading post, which is a virtual eBay on Wyville. And what you can see here, we also studied her changing language. If you see on the 3rd day, she kind of types full language. Just a few days later, she already adapts the lingo online. And so what we did in order to create rich data, we pulled out the log files, and we reconstructed her life based on the log files, day by day, minute by minute, day by day. Lots of undergraduate sweat labor. In order to understand what she actually was doing. And we also did textual analysis of looking at what some of her words were. And we found this word doubled. We didn't know what it meant. So we had to actually go back into the log files of her. And what we found out, somewhere in the 3rd week of her time being on Wyville, she got scammed, and then she turned around the scam and scammed everybody else for 3 weeks. So this work appears around 204 times, and we know by looking at her banking records that she was several times successful before she moved on to another career. And I bring this up as an example of what you don't see when you do big data. And what also you might not see when you do sick data, because this is something, despite the interviews and observation, she shows to be very quiet about. I mean, she realized this was socially not that acceptable, including all the flirting she did as well. So what I'm trying to make a point when we talk about big data, and I think it connects to one of Gordon's point about creating context, that we need to situate the big data analysis with sick data in order to create rich data. And I've actually written a whole book where you can follow the incredible, interesting life of Zoe and everything she does, the good and the bad, where we use this kind of rich data analysis to come to understand what big data gives us and where it also fails, but when both come together on how we can understand participation. We also need to think about broadening participation when we think about gaming, and I think here in particular, this is just one example, and I know people here in serious gaming are much more sensitive to the kind of context which you choose, but I want to point out it's not just about the kind of context and the kind of games which we can design, but also moving beyond the screen in terms of broadening participation. And I'm thinking here gaming doesn't just happen on the screen. It also happens out there in the real world. Most of commercial gaming actually has extensions into the physical world. And I'm thinking about using new materials. And some examples you have here is designing wearable controllers, very much in line with technology developments, but also what you see in the gaming world. So we want to cast a broad net in how we bring people into gaming. And lastly, I want to think about deepening participation. This really has become my pet peeve because everybody talks about broadening and understanding participation, but I think the next challenge is once we get kids there, how do we actually make them proficient? And just last year with Debbie Fields also, we conducted back-end data analysis of Scratch, which now has millions of kids who participate. But who is actually participating? So we drew a random sample in January 2012 up to March 2012, and then looked at who are the creators. And you can see 45% of kids even posted something. The rest logged in, but we didn't see any trace. And then if we looked over a 3-month time period, what we see is that there's a distribution of participation, and the high network kids are the people who are really heavily engaged. And they are also heavily engaged, continue over a 3-month time period. Most participants stay within the laws. This is a latent class analysis which clusters people across the 3 time months and tries to figure out what their probability is in moving from kind of low peripheral participation into higher forms. So what we have here is a pattern which I think is fairly standard in massive communities. Yes, we have large numbers of participants, but we only have a small group of kids who is participating at the most extensive level. And so it shouldn't come as a surprise if you look at programming profiles of what kids actually program, that the smallest class of users are the ones, who are the experienced ones, and the large group belongs into gaming. And if you look just at the programming, these are different concepts which I'm not going to explain in detail, but you can see here loops are very popular and are easily understandable. Something like booleans and variables doesn't get picked up easily by beginners. And so these different classes are pretty persistent. And if you look, you combine the participation profiles with the programming profiles, you will find that the group who reaps the most benefit, obviously, is also the group who participates the most. So we do have inequities online, and I don't have the time to show you the data. There are also gender differences here. The girls are participating, but they do program, just on our rough rudimentary analysis, much less complex programs involving not as many complex concepts. And I admit this is a very rough cut in understanding programming competence. And this is what I mean by deepening participation. It's not just engaging kids in activities, but also helping them understand the more complex concepts. And the reason why this is important, the analysis which I showed you is what I call by programming in the wild. There's no instruction. Kids kind of venture on these sites on their own. And you see a distribution which pretty much replicates the lack of diversity we have in the technology area in general. And I think here is where school and instruction can play a really important role, because joining is hard as a newcomer, but you can, because Scratch and many other programming communities are free. Participating, girls are in lower numbers, that's increasing. But if you think about coding, we only have a small percentage. And school, by instruction, this is the only way we can kind of level the playing pool. So I think broadly, computational thinking is great, but we really should think about it as a form of participation which not just needs to be broadened, but also deepened. And this is an agenda not just for programming education, but I think for K-12 in general. So let me wrap up with a few words on connected gaming. Because why do I think that it's not just making and not just playing games? And here is my answer. 100 million subscribing payers. It never started out with the intent, but I think it's a great example where the making and the playing mode come together. It's too early, there's very little research available, but I suspect you will see very similar pattern what we observed in Scratch in terms of distribution. And we already know that we don't get just by kids putting into Minecraft the full extent of participation. And so for me, when I think about making games for learning, obviously, I'm a computer science educator. I have coding, as a literacy, but my goal is not that everybody becomes a computer scientist. I think about it really as a basic literacy inspired by Sylvia Scribner's 1984 definition of literacy. We all need some kind of functional understanding of how these things work. And there's a political engagement, because all of our life is now mediated through technology, not just the personal, the leisure, the work, but everything. And there's also, I think, in particular for youth, a personal level. We don't talk about it a lot. You know, people in the 18th century used to write love letters. Well, nowadays you compose a 140-character tweet to vote somebody, and that's a skill on its own too. So for me, in connected code, this becomes about the digital public, and I kind of draw an analogy to urban planning, and here in Los Angeles as well as many other American cities, people are aware of how cities moved into disrepair, and by giving people a voice in how their living space is constructed, we were able, in conjunction with other efforts, to turn those into livable spaces again. And I argue for digital publics and spaces, the same argument applies. Thank you.